Now that we've learned how to factor polynomials, solving them is very easy. It's just one extra step. So now we have a polynomial equation, so with an equal sign, and the first thing we want to do is set it equal to 0. So we want to move everything to one side and make my equation equal to 0, and then we're going to factor and use the zero product property to solve each mini equation. So just like what we do when we solve quadratic equations, now we have polynomial equations. So let's start by factoring. My first example, 2x cubed minus 12x squared plus 10x, is already set equal to 0, so I'm ready to factor. Looks like my GCF, I can divide out a 2 and an x from every term. So I'm going to divide out the 2x, and I'm left with x squared minus 6x plus 5 equal to 0. Remember, the 2x that you divide out does not go away. It stays as is in the front. And then from there, I want to factor this quadratic out, x squared minus 6x plus 5. So the 2x stays out here, and I'm going to factor out the quadratic. So you can either use guess and check, or you could use the x factor method. We want factors that multiply to give me a times c, which in this case is 5, and add to give me b, which in this case is negative 6. So two numbers that multiply to give me 5 and add to give me negative 6 is negative 5 and negative 1. That's how I'm going to split up my middle term, negative 6x. So x squared, negative 6x is going to break up into negative 5x and negative 1x plus 5 equal to 0. Don't lose the equal to 0. Once I break it up into 4 terms, I'm going to go ahead and group them and then take out the GCF from each group. So from my first group, GCF I'm going to take out is x, and I'll be left with x minus 5. And from the second group, looks like the only GCF I can take out is negative 1, and I'll be left with x minus 5 as well after I divide out a negative 1. And then from both of these groups, we notice that we have x minus 5 in common, so I'm going to take that out. And this 2x that you have in the front, if you want to put a parentheses around it, you can. You don't have to. It's one factor. It just doesn't have a plus or minus in between. It's a factor with just one term, and that's okay. And then my other factor is x minus 5, what they have in common. And my third factor is x minus 1. And then after I factored, notice that none of my factors are quadratic, so I don't have to worry about factoring even further. This is it. I can't factor any further. Now we're going to use the zero product property, which really is just saying that if you have three numbers, a times b times c, that multiply to give me 0, we can conclude that one of them has to equal 0, right? If three numbers multiply to give you 0, one of these has got to be 0. So using the same property, I have three factors that multiply to give me 0. 2x, x minus 5, and x minus 1. In order for this to be true, one of these factors has to equal 0. And so we set them each equal to 0, and we solve each mini equation. Either 2x is 0, or x minus 5 is 0, or x minus 1 is 0. And we divide by 2. X could be 0. That's one answer. Add 5. X could be 5. That's my other answer. Add 1. X could be 1. That is my third answer. So this problem has three solutions: 0, 5, and 1. And if you look at the polynomial, it's a cubic polynomial, x to the third power. These solutions are also called the zeros or the roots of your polynomial, and it corresponds to, if I were to graph this equation as y equals 2x cubed minus 12x squared plus 10x, it represents the x-intercepts of your graph. So we know that this graph intersects the x-axis 3 times because it's a cubic polynomial. It's a power of 3. So remember, when we're solving quadratics, we could have at most 2 solutions because my parabola can only cross the x-axis twice. But when you have a higher degree polynomial, the number of solutions that you can have is actually equal to the degree of the polynomial. So cubic, you could have up to 3 solutions. Okay, let's try one more, and we're going to do the same thing. We're going to set it equal to 0, which it already is, and then we're going to factor out the GCF, keep factoring, and then we're going to use the zero product property. So in this case, my GCF is 4x. I can divide out a 4 from both terms, and I can divide out an x. So 4x comes out, and I'm left with x squared minus 25 equals 0. And this x squared minus 25 is a quadratic, right? It just doesn't have 3 terms, so it's not as what we normally see it as, ax squared plus bx plus c. But in this case, the b is just 0. So we're going to still try to factor it using our ACB method, or the x factor chart. I want factors that multiply to give me negative 25, that's a times c, and I want it to add to give me b, which is 0 in this case. Okay, so 2 numbers that multiply give me negative 25 and add to give me 0, that would have to be 5 and negative 5. And that's how I'm going to split it up. So 4x stays out. If you want to put parentheses around it, that's fine. And then this 0x in the middle, so I'm just going to write it like this so you know it's the 0x. We're going to break that up into 5x and negative 5x. So you're really just trying to factor it the exact same way when you have a quadratic. And then once we have 4 terms, we're going to group them. And so we've got 4x, and then the GCF of the first group is x, and I have x plus 5 left over. GCF of the second group is negative 5, and I have x plus 5 left over again, which is what I want. And from both of these groups, I have x plus 5 in common, so I'm going to take that out. 4x is still out here. X plus 5 comes out, and I'm left with x minus 5, and these are my 3 factors. None of them are quadratics anymore, so I don't have to worry about trying to factor them further. And then I'm going to apply the zero product property. If 3 factors multiply to give me 0, one of them has to equal 0. So either 4x equals 0, or x plus 5 equals 0, or x minus 5 equals 0, and you have 3 mini equations that you got to solve. Divide by 4, x equals 0, minus 5, x equals negative 5, and add 5, x equals 5. And those are your 3 solutions. And again, if you want to check to see if you're right, you could also always plug 0, negative 5, and 5 back in for x and make sure that it makes the equation true.